So this is the homework that was assigned on Tuesday, January 17th, 2017, and we checked it on Wednesday, January 18th. So here are the problems that I had asked you to look at, and here's what we would need to do on these. So writing this in terms of log 2, or natural log of 2, and natural log of 5, I know that 200 can be broken down into 2's and 5's. So for example, maybe I know that it is the natural log of 2 times 100. I know that fact. Now, because it is multiplication, I can split this into logarithm addition. But I know that I can actually go farther than that, right? There's my ln of 2, but my ln of 100 still would need to be broken down more, so let's go farther. I know that this would be 2 times 100 might be 5 times 20, for example. There's my 5, that's good, but this 20 I can break down even farther. So I'm going to have the, in the end, natural log of 2 times 5 times 2 times 2 times 5. That order isn't necessarily important. When I backwards here. When I break this down with logarithmic addition, I see I have the natural log of 2 plus the natural log of 5 plus the natural log of 2 plus the natural log of 2 plus the natural log of 5. However, I can clean this up a bit. I have 2 natural log of 5's, so I'm going to bring them together. Plus 1, 2, 3 natural log of 2. So that is my final answer there. So take a look at that. That's not the only way to do that problem. If you maybe by chance knew that when you divide 200 by 25, you get 8. We know that that is 5 squared and 2 to the third power. Break that up with addition, take my exponents in front, and you get this same answer. So that's your first question. And then number 10 is very similar. This one I see pretty clearly that 7 squared I know is 49. 3, I'm thinking, I know it goes into 81 somehow, checking real quick. 3 times 3 is 9, so 3 to the fourth must be 81. Since that's 3 squared, 9 squared is 81. So I'm going to rewrite this as the natural log of 7 squared over 3 to the fourth power. Because this is a division problem, I can rewrite this as a subtraction of 2 separate logarithms. And because they both have exponents in the logarithm, I can take that exponent and multiply it out front instead of inside. There is my final answer, written in terms of natural log of 7 and natural log of 3 with their coefficients out front, 2 and 4. And we are subtracting. There we go. Good. Okay, let's keep going. Number 24, I am evaluating this craziness right here. I see that the 3 is just being multiplied out front, so I'm just going to keep that there. I can rewrite this as log 7 of 49 to the 1/6 power. That exponent of 1/6 can be multiplied out front. There is already a 3 there, so I'm going to multiply 3 and 1/6, which is 3/6, which is 1/2. So I have 1/2 log 7 of 49. Again, remembering, once the exponent is multiplied out front, we don't need to see it anymore. And this part I can do in my head. 7 to some power gives me 49. Well, I know that answer is 2. So I have that 1/2 times 2 gives me my final answer of 1. There we go for number 24. Last two, I'm asking you to expand these guys. So for this one, expanding, I see a lot of stuff going on. Again, remembering there's no rule, there's no protocol for logarithms where the inside is subtraction. So I'm thinking this 3q minus 1 has to be locked together at this point. Everything else I can separate though. So I see in my numerator, I'm going to have log base 3. I am dividing here. So in the numerator, in the first piece, I have p squared q minus the logarithm of 3q subtracting 1 to the 1/5 power. That's my 5th root, where that comes into play. So then This guy I can split up even farther. Adding, since I am multiplying here, adding log base 3 of q minus, and out here I can start a while. This 1/5 is going to come down out front just of this specific logarithm, just in front of that specific logarithm. 1/5 log 3 of 3q minus 1. That does not get separated because it is subtraction within a logarithm. There is no rule that says I can do anything with that. Last thing is this exponent, I'm going to make this 2. Log 3 of regular old p plus log 3 of q minus 1/5 log base 3 of 3q minus 1. And that is my final answer there. This one is going to be pretty straightforward as well. I am multiplying everything. I see that I am multiplying the a and the b and the c and the d. They all have exponents except the a. That's okay. So what I'm going to have here is log 11 of a plus log 11 of b to the -4th plus log 11c to the 12th plus log, running out of space on the paper, log 11d to the 7th power. The exponents are going to come out front, so the a stays put, log 11a, minus 4 log 11b plus 12 log 11c plus 7 log 11d. And that is my final answer. So take a look at those. If you have any questions, let me know. And I will upload the next video soon for the lesson we did on Wednesday. Alrighty.